And hello everyone, I'm glad to be here to share the running and observing rules application on GKE for you. And actually, this is my first attempt to have an English presentation, so that might not be so fluent, but I'll try my best. Okay, and oops. Is that a network problem? Okay, let's get it. It's just an introduction. Yeah, so I'm Li Feng and I'm working at iCala, which is the AI marketing technology company based in Taiwan. And I'm the tech lead of Shop Plus product line. The Shop Plus is a social selling tool to help e-commerce seller to selling things on social network. And we are targeting the South Asia market. And you may not know that in South Asia market, most of the sellers are selling things and buying things on social network. For example, about 87% of the Vietnamese are having experience to buying things on social network, and it's not like the way we familiar with on the North America or in Taiwan. Okay, then anyway, let's get to the topic. Okay. Okay, today I'm here to share this topic is because Kubernetes, if you know, it's becoming a new standard of infra. And so no matter what cloud service you are using, and you are facing a new standard. And the way we use to deploy, to run and observe our REST application is no longer valid. And when it comes to Kubernetes, we have to fit in a different way. And so we go through this journey from the old VMs world to the Kubernetes setup. And so we would like to share the challenges and the goods in the cloud native way with experience. Yeah. And because one of our company's product line, GCP Expert, is also one of the biggest partners of Google in APAC region for the cloud business. So we are more familiar with and having been focused on GCP for a long time. And so today my share will focus on our experience on GKE, which is the GCP's Kubernetes provision. Okay, clear? Okay. Okay. And as I mentioned before, that I'm going to share our experience in about 3 different categories about deploying, running, and observing the ROS app. So let's start the first part, the deploying. Okay, let's start this by take a look for traditional deployment setup with the VMs for ROS app. Yeah, and as you can see, we got a code repository, and we have a CI/CD setup, and which is Jenkins in our company setup. And when the code is merged into code repository, then Jenkins will be triggered to execute Capuchino command to complete the deployment. And that should be a widely adapted pattern. So yeah, and Okay, I'm wondering, is any of you are still using Cappuccino? Or, okay, there are still somebody using it. Yeah, so you should know this tool. No, and then how do Cappuccino complete his job? The Cappuccino just go into the VMs and pull out the code and do the migration and then complete the release. And that's what we used to do, yeah, in the past time. And let's get to the deployment setup for the Kubernetes now. And the main difference here is what we are no longer dealing with the VMS. We are only communicating with the Kubernetes cluster, and they do the magic. And today I'm not going deep into the Kubernetes because it's not today's topic's purpose. Want to tell you, but so I will skip the detail about the Kubernetes, but we'll give you a whole structure about the Rails application, how it will look like to fit in the Kubernetes. Okay, and okay, then how do we turn from the old VMwares into the new Kubernetes way? And so we got 3 things to do and check. And the first one is the deployment automation. And for the deployment automation, there are some challenges. I think the major challenges is the steep learning curve for the Kubernetes. Yes, indeed. Yeah, but still, I'm not going into the detail into it. And besides on that, you also have to adopt maybe the group control, which is the command to Kubernetes building, or other open source tool like Helm or Customize to achieve the deployment automation, just like Cappuccinos do. Yeah, and yeah, since I'm not going to go deep into Kubernetes, so I just list the challenge here. If you you are thinking about changing your current design into a Kubernetes way, yeah, and then the goods, yeah, if you go across the challenges, then you will have the fully automatic managed infra. Okay, and the second one is building Docker image. Yeah, since Kubernetes is so-called Docker orchestration system. Yeah, so it runs Docker image, of course. Yeah, and so let's focus on this part. To the new deployment setup, and the Jenkins not execute Cappuccino anymore, and by execute maybe Helm methods, and there must be a cycle inside the execution, like to build a Docker image. Yeah, and then when it comes to building a Docker image, there are some challenges. The first one that you might need to shrinking your Docker image size, because it's related to how your system runs. And if you get smaller Docker images, your system will will start faster. Yeah, and the second one is you might have to shortening the Docker main image build time. And let's see what happened. And why you need to shrink Docker image size? Because in the basic Rails setup, if you grab some maybe Ubuntu-based image or Debian-based image, and then add on your Rails application code, and you do the bundle install, the size can be more than one G very easily. Yeah, but that's really huge. And actually, it could be reduced into around 100 mega. And how do we do that? And you could use smaller base image like Alpine Ruby. And there's some technique that is about the Docker. Yeah, and you can reduce your Docker layers in your Docker file. And that is the example. You can see that actually it's the result is identical, but only the size is different. Yeah, because every layer you add on, you add a size to the Docker image. Yeah, so just to give you some ideas. And the second one is to for the build time. You can imagine that for every time you do the deployment, and you have to build the Docker image. If you have to run the full bundle install on every deployment, it's really time consuming, right? Because the bundle install may take about 5 minutes. Yeah, so there's a trick to solve that problem. Yeah, we can utilize the Docker's cache mechanism. Yes, as you can see that since Docker will catch any add, copy, or run command, and the Docker will see that if there's any change happen there, and if no, they will reuse the cache. Like maybe the first time you still need to do the whole bundle install, but the second time, if the gem file is not changed, and Docker will know that and just skip the whole skip to the next step. Yeah, so that's how we accelerate this process, and it could be down to 1 minute in our experience. Okay, and we get to the challenges, and the good is that when you have your Docker image and you can enjoy build once, run anywhere. That's you will have different version code on your different environment. Yes, that's the benefit. Yeah, and about the third one, it's about auto scaling and about the deployment strategy. Okay, and in the old-fashioned way, in the VM style, and how do we do auto scaling? The reasonable method is to just do the VM clone, just clone the VM to do the auto scaling. Yeah, but in Kubernetes, the Kubernetes cluster will do it for that. You just need to config what's need to be scaled and what's your expectation on the scaling metrics, and Kubernetes will do that all. And so the auto scaling will be from the VM level turn into a service and pod level, and and also the deployment strategy will go from the blue-green to the rolling update. Let me explain it a little bit. Yeah, the blue-green fashion release is somewhat like the default of Cappuccino setup. Yeah, what's blue-green? That is when your code is deployed onto the VM and it's ready to release. It just change the link to the new code, and so it just released for several VMs at the same time. So it's just like a switch, and you turn into the new version. So we call that like blue-green release. And another one is rolling update. It's like if you have like maybe three instances running one service, and then the rolling update will close one by one and create a new version of that service one by one. Yeah, as you can see that the difference is here. Yeah, and actually Kubernetes, you can still choose using blue-green release on Kubernetes deployment. Yeah, but as you can see, the difference is on how they consume the resource. When you do the blue-green release, you have to prepare for double resources because you have to prepare for the new one and let the old one still running. And when the new one's ready, you switch to the new one. Yeah, so you need double resources. And so the rolling update is the most efficient way. Yeah, so that's why it's recommended to keeping in a rolling update fashion. Yeah, and so the challenge will be if you were using the blue-green strategy and now you turn into the rolling update, you have to check if there's any problem on your system. Yeah, and if you check and you're good. Yeah. Okay, then. Okay, that's all for the deployment part. And so let's get to the next part, running the application. Okay, what's the difference? Okay, the first one to check or to do is about running scheduler and worker. And we often need a scheduler or worker system in our REST application. That's often, yeah, but how we used to do is like integrating gens like whenever. Yeah, do you guys know that? Okay, yeah, so the underlying information is by insert it into the system's cron jobs. Yeah, and in the Kubernetes, we no longer need to set up like that. We just need to set up a standalone scheduler. It's a standalone service like your API, like your worker, like your web instance. Yeah, that should be a separate scheduler. And in the old fashion, we need some process monitor for the worker. So because the worker sometimes crash, yeah, and we need to recover them. So we need to integrate something like the guard or something else like that. Yeah, and in the Kubernetes world, we no longer have to take care of them. The Kubernetes will just take over. If this service or instance crash, and you will just recover automatically. Yeah, so that's the difference. So that's the good. So we no longer to set up the process monitor, and scheduler got the same service abstraction. Yeah. Okay, and the second one is dealing with the data. And when it comes to GCP, it's all convenient, yeah, because all the data store there has one managed service like Cloud SQL serving RDBMS, and it include PostgreSQL and MySQL as well, and Cloud Memory Store actually is the Redis, yeah, and it's also managed and auto scaled, yeah, and the last one is the super scale message queue, yeah. It's called Google Cloud PubSub, yeah. How do I say that is super scale? Because it's mentioned by their service, by their own, they say it's Google Scale Messaging Service, which is 500 million messages per second they can handle. Yeah, so that's really it's super huge. It's super scalable, and There's only one thing you should taking care of that, because when you using you want to run a message queue, in Rails there's already an abstraction for that. That is the active job. So as I know, the most popular active job integration is the Sidekick, but that is depends on the Redis. Yeah, but it's not a message queue. Yeah, but anyway, when you come to the GCP and you have a powerful message queue, so you should use it. And the only thing you have to take care of, you should have an active job adapter to hook on the Google Cloud pops up. Okay, and there are another one thing about Google Cloud pops up, and when you since it's a pops up architecture, someone can publish messages, and another one can make a subscription to take the message. But if any of the system are not inside your network and also want to receive the message, you can utilize the Cloud Pops Up method. It can turn the message into a webhook code. So if just throw a message into the message queue, and they will do a webhook code for you. That's a really useful one. Yeah, that's come in the GCP. Okay, and the last one for the running is the security and access control. And there are two things is worth to share to you. And the first one is carefree SSL setup. And the GCP provide a service called managed certificates. And sometimes setting SSL for your server is a tedious job. Yeah, but within GCP with Kubernetes, you can do. Although I'm not going into the Kubernetes, the detail of Kubernetes, but just to give you an idea, if you want to set up a SSL certificate, and it's provided by the Let's Encrypt and integrated by the GCP, for sure, and you just have to set some config like this, only like this. You will have, you can see the domain. You just type the domain here, and the certificate name here. It's just this one, and mapping to your service, and you are done. And you can have the SSL, and it takes you only a few minutes. Yeah, it's really useful. And the second one is the so-called identify a web proxy, IIP. It's provided by the GCP. It's really useful for setup a main panel. What is it? And the Google will make the authentication and for you. And what it works like, and when you attach one of your service into the IAP, then the Google will just protect your service. Yeah, and you can only allow the specified Google account to get into your service. If your Google account is not specified in this service, you cannot even get into the service, just like that. If I go to this so-called IAP protected URL, and I'll be blocked by the Google. And this request won't even reach to your service. You will just block by the Google. And that's really useful if you want to craft some of the main panel and maybe you should have to set up some VPN to allow only your staff to get in, or you have to set up some firewall rules. But with IAP, you don't need them again. Yeah. Okay, that's about the running part. Okay, the last part, observing. Okay, as you might know, the three things in observability is tracing, logging, and metrics. And so I'll go one by one. And the first one, tracing, is to sorry, that's nothing special. We are still using New Relic. And although there's a stack driver trace that GCP has provided, but we never tried it. Yeah, but maybe you can just take a look what it looks like. Yeah, I think you could do the detailed job. Yeah. Yep. Okay, so let's just skip for the tracing part. And to the second part, logging. And from our past experience, we are integrating the logging with the so-called EFK stack, and someone used ELK stack. Yeah, that's Elasticsearch, FluentD, and Cabana. And so we collect our logs data into the database so we can query on. And for the when it comes to GCP, it's very easy to integrate with because we just use stack driver logging directly, and we don't need to set up anything. It's just there. And the logs comes from GKE's stdout. Yeah, so if you just print out in your Kubernetes service, print out anything, they will go into the stack driver logging automatically. And of course, all the logs from the GCP services, like the load balancer or like some Kubernetes cluster, all the logs will go to the stack driver logging directly. Okay, so and that's what Cabana looks like. Yeah, that's the Cabana. Yeah, and this is the stack driver logging. Yeah, I think it's the only one thing that Google a stack driver logging missing is the visualization part. I think except that there's nothing different, and I can do very complex search in the Google stack driver logging. And in my opinion, and I think the syntax for the search is even better than the Cabana. Yeah, so I'm pretty satisfied for stack driver logging. Yeah. Okay, and to go deeper for the logging, and the stack driver will pass JSON string into structured queryable JSON payload. So if you print out your logs in a JSON format string, then the stack driver will pass into a structure data, and then you can query by the structure. Yeah, I'll give some example later. Yeah, and so we have done further to make it more suitable for our Rails application. We just we centralize our Rex log setting, and we utilize logreg and active support notification to output our structured logs. Do any one of you know what it is? Active support notification. Is there anyone using it? Okay, that's okay. I will show you some example later. And just to clarify the flow, on how we collect the structure log from Rails application. And in our application, we will use the active support notification to instrument our code. And then we will use the active support notification to subscribe for that instrument, and then print it out into Rails stdr. And then the GKE will just flow into the stack driver logging. Yeah, and for your better understanding, this is an example for the active support notification. We can just subscribe some events, and this event is built by the Rails. It's already there. You just need to subscribe it, and you can get it. When you do a active record query, you will get this event. Every time you do an active record query, there will pop out this event. And then we turn this event into this structure. Like we can set up the type and the information we need and output as a JSON string. Then it will be parsed by the state driver logging. And then we can query on all these attributes, search by all these attributes. Yeah, and that's another example. Not only the active record filing the events, like active job are also filing the event, and that's also the building one. We are not just using the building event. We are also sending our create event, and then we'll subscribe them, and then output the structure logs. Yeah, and by doing this, we can centralize all the logs process into one place. You can say what logs coming and what structure do we output it. Yeah, then that's the how we do that. Yes. Okay, so that's for the logging. So we send all the Rails data to the logging. Yeah, and then let's go further to the metrics. We used to use some in-house solution. You can imagine it's something like Prometheus. If you are familiar with that, that's for collecting metrics. But yeah, when it comes to GCP, we can just use state driver monitoring and Kubernetes monitoring directly. Yeah, and there's a logs-based metrics I'll explain later. Okay, the monitoring and Kubernetes monitoring are collect the metrics from the GCP provided service, like just I said, a load balancer or something else like Kubernetes clusters. And the most interesting point is the log-based metrics. It can turn your logs into metrics, and as I say, we just send out all our data into the logs. So ideally, we don't have to integrate other metrics tool to collect metrics from our application. We just need to sum up or just turn the logs into the metrics, and GCP can help on that. Like maybe we can just make some query, like the type is just like the example I shared to you. Yeah, then we can narrow down the query into into some condition we want. Like this one, we just want to know the request count for one of our service. And I just, for this query, I just filter out all the, only the query, only the request, page request, and the logs about the SQL or about active job will not appear below. Yeah, that's only for the web request. Yeah, and then we can turn it, when we filter out, then we can turn it into a matrix. We can give that a name, and that's what's so-called log-based matrix. So I think it's imaginable, right? Since you have all the data in logs, you should be able to summarize them into a matrix, right? Okay, so it's the tools for that. So when we have the log-based matrix, then we can just draw the matrix out, and then we can set up the alert when the matrix is abnormal, just like every matrix you are using. Yeah, that's a very useful part on GCP. Yeah, and of course you can still integrate with maybe Prometheus or other metrics tool into the Kubernetes ecosystem. But I think that one, the log-based metrics, you might not know about that. So I'm happy to introduce that to you. I think that will help you to get your traditional deploy into the Kubernetes one, and that will be an easy way for you. Yeah. Okay, so that's all. So thank you. Yeah.
Okay, thank you, Li Feng, for the talk. So since we have a few minutes left, so any questions for Li Feng? Yes.
The scheduler. So as I mentioned, in the traditional, we all use the whenever, and we define the scheduler task, and when when you do a deployment, and you will turn whenever's definition into the cron job. Yeah, and for the standalone service, you may think like it's a worker. Yeah, but it's since it's a scheduler, so there won't be no redundant worker. There's only one worker. Yeah, if you have redundant one, then you will fire the event twice or even more. Yeah, so it's just a standalone service or worker. You can think like that. And you can just search like scheduler gems, and you might find some gems are doing this already. Yeah, and it fits very well into the Kubernetes system. Okay.